All right, let's get this going. All right, we're going to be doing some exorcism. I've been putting this off for a long time and finally realized I just need to get over myself. Might as well struggle in public if that's how it's gonna be. All right, so we're going through the C# track as interview prep, and we got up to the exercise on dictionaries, which is International Calling Connoisseur. Learn about dictionaries by keeping track of international dialing codes. Now, I had already started porting this to Clojure, and I don't even remember how far I got, but let's go check it out. So yeah, the directory is here, and yeah, it looks like this was pushed 9 months ago. Here's the source code. Oh yeah, that's the stub file. Kind of uninteresting. It's just blank function stubs. Here is the exemplar file. So yeah, this is the example solution. And wow, that in Clojure, that's actually exceedingly simple. It's going to be much harder in C#, I imagine, because I don't really know C#, but I have an interview coming up. And it should be pretty fun. They actually know that I'm on the autism spectrum and are going to be making accommodations for me. So that is very interesting. I actually only discovered this fact about myself quite recently. And I also experience unmedicated ADHD, which kind of has been the inspiration for this entire streaming workflow. I do this partially to keep myself focused, and it turned out that it's actually led to a kind of a superpower, because I do all of my work live on stream, which means I can never forget. Well, that's not true. I will always forget what I do, but everything is documented. It's almost too perfect. So I imagine that this is missing documentation. Yep, there's no introduction. I doubt there's no hints. And okay, we have instructions, so that's something. So what I'm going to do first is try to solve the exercise in C#, because first and foremost, I need to learn this. And then if there's any time left, or rather, if I have any energy left after this, then we can work on porting some stuff over.
Back to exercise. Introduction. A dictionary is a collection of elements where each element comprises a key and value such that if a key is passed to a method of the dictionary, its associated value is returned. It has the same role as maps or associative arrays do in other languages. A dictionary can be created as follows. New dictionary int string / empty dictionary. Or new dictionary int string 1 = 1, 2 = 2 / or new dictionary int string 1 1 2 2 / 1 = 1 2 = 2. Note that the key and value types are part of the definition of the dictionary. Once constructed, entries can be added or removed from a dictionary using its built-in methods add and remove. Retrieving or updating values in a dictionary is done by indexing into the dictionary using a key. var numbers = new dictionary int string 1 1 2 2 / set the value of the element with key 2 to ducks numbers 2 = ducks / get the value of the element with key 2 numbers 2 / ducks. You can test if a value exists in the dictionary with var dict = new dictionary string asterisk dict dot contains key, some key that exists / = true. Enumerating over a dictionary will enumerate over its key value pairs. Dictionaries also have properties that allow enumerating over its keys or values. Instructions. In this exercise you'll be writing code to keep track of international dialing codes via an international dialing code dictionary. The dictionary uses an integer for its keys, the dialing code, and a string, country name, for its values. You have 9 tasks which involve the dialing code's static class. Task 1. Create a new dictionary. Implement the static method dialing codes.getEmptyDictionary that returns an empty dictionary. Dialing codes.getEmptyDictionary / / empty dictionary.
Okay. So first, we just want to get an empty dictionary. So that'll be this method here. It showed us how to do this up here, did it not? Yeah, new dictionary int string. So we're going to return a new dictionary which will be an integer and a string. Okay, let's see if that works by running the test suite. Okay, cool. We're already up to task 2.
Back to exercise. Create a Task 2. Create a pre-populated dictionary. There exists a pre-populated dictionary which contains the following 3 dialing codes: United States of America, which has a code of 1, Brazil, which has a code of 55, and India, which has a code of 91. Implement the static dialing codes.getExistingDictionary method to return the pre-populated dictionary. Dialing codes.getExistingDictionary / / 1 = United States of America, 55 = Brazil, 91 = India. Stuck.
Okay, so here we need to create the pre-populated dictionary. So that will be this getExistingDictionary method. And so we will be returning a new dictionary. Which will consist of an integer and a string. And we'll place it in these brackets. So what did we need? It's going to be okay, we have 1 mapped to United States of America. And 55, which is Brazil. And 91 is India. And, oh, I didn't put India in quotes. How silly of me. Okay, that was task 2.
Back to task 3. Add a country to an empty dictionary. Implement the static method dialing codes.add country to empty dictionary that creates a dictionary and adds a dialing code and associated country name to it. Dialing codes.add country to empty dictionary 44 United Kingdom / equals 44 equals United Kingdom.
Okay, so here we implement add country to empty dictionary. So this will create a dictionary and add a dialing code and associated country name to it. So it will be the same as before. We'll return a new dictionary. With the same types. We will add the country code and the country name. Okay, going good so far. I'm already up to task 4. How many are there total? 9. Okay.
Back to task 4. Add a country to an existing dictionary. Implement the static method dialing codes.add country to existing dictionary that adds a dialing code and associated country name to a non-empty dictionary. Dialing codes.add country to existing dictionary. Dialing codes.get existing dictionary 44 United Kingdom / equals 1 equals United States of America 44 equals United Kingdom.
Okay, so here we're going to be adding a country to an existing dictionary. So this takes an existing dictionary and we will add to it the country code. And set that to the country name. And return it. Okay. Task 5.
Back to exercise. Get the country name matching a dialing code. Implement the static method dialing codes.getCountryName from dictionary that takes a dialing code and returns the corresponding country name. If the dialing code is not contained in the dictionary, then an empty string is returned. Dialing codes.getCountryName from dictionary. Dialing codes.getExisting dictionary. 55 / equals Brazil dialing codes.getCountryName from dictionary. Dialing codes.getExisting dictionary. 999 / equals string empty.
Okay, so get country name from the dictionary. First, we have to check if the dialing code is not contained in the dictionary. So let's check if it is in the dictionary, and then if so, we will return it, and if not, we will return an empty string. So let's test whether existing dictionary, and we can use the contains key method. And check if the country code is contained in the dictionary. If so, we will execute this block where we'll return existing dictionary country code. Otherwise, and we can use string.empty. All right, task 6.
Back. Check that a country exists in the dictionary. Implement the static method dialing codes.checkCode exists to check whether a dialing code exists in the dictionary. Dialing codes.checkCode exists. Dialing codes.getExisting dictionary. 55 / equals true.
Okay, so check code exists. You know, I think that's actually going to do the same thing as this. We'll return the existing dictionary contains key country code. Okay, we're rolling along.
Back to exercise. Task 7. Update a country name. Implement the static method dialing codes.update dictionary, which takes a dialing code and replaces the corresponding country name in the dictionary with the country name passed as a parameter. If the dialing code does not exist in the dictionary, then the dictionary remains unchanged. Dialing codes.update dictionary. Dialing codes.get existing dictionary. 1. Les Etats Unis. / equals 1 equals Les Etats Unis. 55 equals Brazil. 91 equals India. Dialing codes.update dictionary. Dialing codes.get existing dictionary. 999. Newlands. / 1 equals United States of America. 55 equals Brazil. 91 equals India. Stuck.
Okay. So this is the update dictionary method, which takes a dialing code and replaces the corresponding country name in the dictionary with the country name passed as a parameter. If the dialing code does not exist in the dictionary, then the dictionary remains unchanged. So let's test for that first. And we can copy our trusty code right here to grab the country code if it exists. And if so, then we will set that to be the country name. And return it. All right.
Back to Task 8. Remove a country from the dictionary. Implement the static method dialing codes.remove country from dictionary that takes a dialing code and will remove the corresponding record, dialing code plus country name, from the dictionary.
Okay, so this should be pretty straightforward. We just we can call existing dictionary.remove. And return the dictionary. Okay, so it looks like we just have one task left. This is going faster than I thought.
Back. Task 9. Find the country with the longest name. Implement the static method dialing codes.find longest country name, which will return the name of the country with the longest name stored in the dictionary.
All right. So we're going to need a variable that we can use to store the longest country name. And so that will be a string, and we'll call it longest country name. And set it to be an empty string initially. Now we need to iterate through the values. So for that, we can use the for each loop. So for each string, which will be the country name, in the values of existing dictionary, so existing dictionary dot values, so we need to see if the length of the current country name is greater than the string that is currently the longest country name. So let's test that. So we check the country name, get its length, and see if that is greater than this. And if so, then we'll set that to be the longest name. And when we're done with all of those, we'll return the string. All right. Wow, that was that was a lot easier than I thought. So I'll mark that as complete. Share it with the community. And we'll see what concepts we unlocked. Yeah, it looks like was enums unlocked before? I don't know. So since that went a lot farther than I thought, or a lot faster than I thought. Oh, hey, we had somebody here. I wasn't even paying attention to the chat. Actually, I thought it was, I have a chat window up here. Apparently it doesn't work, so I'll just close that. Let's see, I'll put, all right, so let's go to the C# version of this. So I'll open up another window and we'll go into the GitHub repo for C#. I just got a phone today and I'm not sure how I feel about that. Hey, what's up, Gabriel? This is my YouTube debut. time to try to broaden my audience a little bit. I've been putting it off forever because, I just need to get over myself and not be afraid to let everyone see how terrible I am. So what I'll do is open up this repository locally. And what I'll do is first I'll synchronize it. And my VS Code was just updated, which broke my... there's a hack that I'm using that lets me have the cool background. But every time that it updates, it breaks it. And so I have to set it up again. But luckily it's pretty easy. All right, this is the Wizards and Warriors branch. Yeah, that's what I was working on last night. It was the exercise that teaches inheritance. And I realized that I could port it to the Clojure track and it could teach, the way that Clojure accomplishes polymorphism is with either multi-methods or protocols. So it could be an exercise on either one of those. Probably multi-methods because they're a little bit simpler. But let's see, what I need to do is to get a clean working tree here. So all right, so I'll just call this init exercise. Now I'll switch back to the main branch and we'll start a new one called International Calling Connoisseur. How do you spell connoisseur? It's it's S-S-E-U-R. Okay. So yeah, I don't even remember when apparently it was 9 months ago that this code was checked in, and I have not looked at it since, except for, half an hour ago. So it looks like I have the example code in the test suite, and the instructions. So the next step would be to do the introduction, I'd say. So I'll go over and grab that from the C# track, and we'll see what, actually it should probably just port over rather cleanly, except I'll just change dictionary to hashmap. It might be that simple. And yeah, because I realized just last night when I was doing the exercise on multi-methods, multi-methods create polymorphic functions that can dispatch on any arbitrary, anything you want. So if you have like a hash map with a configuration of something, you can dispatch on any key or value in the hash map. And so then I realized that I needed an exercise on hash maps in order to introduce the topic before that. So this will pave the way for that. I'll just get the raw file here and paste it right into my editor. Oh yeah, now it tells me that my VS Code installation is corrupt. All right, so a hash map is a collection of elements where each element comprises a key and value such that if a key is passed to a method of the dictionary, its associated value is returned. Okay, so if a key is passed to so that's kind of how in Clojure you can call a key of a map like a function. Now, let me go into the example code and I'll actually fire up a REPL and get the project running. And I need to familiarize myself with the code. So that's the function stub, which I'll go into the meta directory and get the solution code and just paste it in here. And I will connect to a REPL in this directory using Babashka. And let's see. I've been really enjoying using RCF by Hyperfiddle to do inline unit tests so that you don't need to switch files all the time between the source code and the test suite. It works great, but since the test suite is already developed, I don't think there'll be much of a need for that. And yeah, here I have a comment block already. So I will just execute this whole file. And here we have a get countries 1. So here we have the map of countries. And yeah, that's using the get function. Now, it's interesting because it's more common for the keys in Clojure maps to be, well, keywords, which can be called like a function. But okay, so we're not even using that in this exercise, which is kind of a shame. Actually, it might be good to actually demonstrate that, because that's kind of a key feature of Clojure maps, is the ability to have the keys look themselves up in the map. So let's see. In C#, if a key is passed to a method of the hash map, so that's like what we did over, let's go back to the exercise here. So how would I want to describe that in Clojure in the simplest possible way? Let's see how maps are described, how Clojure maps are described in other places. There's free code camp. How about Clojure for the brave and true is always a, oh yeah, hash collections in on the Clojure website. That's a great place to start. Yeah, so looking up by key, okay. Maps. Maps are commonly used for two purposes: to manage an association of keys to values and to represent domain application data. The first use case is often referred to as dictionaries or hash maps in other languages. I could actually just copy this because that's a nice, concise explanation. And yeah, here they're using strings as keys. And it's adding, using assoc, removing with dissoc, looking up by key with get. I didn't even know that you could do this. Looking up with a default for a fallback to a default value if a key is not found. And we use contains to test. So that those must be all what we did here. Yeah, cool. I think I'm just going to get rid of that. That's good enough for me, short and sweet. So, creating a literal map, it really couldn't be simpler. It's almost trivially simple. That's what's great about Clojure. I mean, we could technically use the hashmap function to create a map from another collection, but I've almost never seen anyone even do that. So yeah, this enclosure is just this. It's almost there's almost no point in you just it's a map. Congratulations. Or okay, so there is the hashmap function. Should we even bother mentioning that? Let's see. Create hashmap the long way. Yeah, so we could call hashmap. Yeah, why not? We'll show the long way first, I guess. Or simply note that the key and value types are part of the definition of the dictionary. I don't think that's relevant. We should mention that that it doesn't matter what the types are. Let's see if it says that here. When Clojure prints a map at the REPL, it will put commas between the key value pairs. That's just for readability because commas are white space. I think it probably said previously that all of the Clojure collections are heterogeneous. It doesn't matter what types they are. I think I said that in the vectors exercise. Let me just to keep a consistent wording. And oh, not concepts. This was exercises. This was the bird watcher exercise. A vector in Clojure is a sequential, indexed, immutable collection of 0 or more values. Yes, the values in a vector may be of is it heterogeneous or heterogeneous? I don't know. The values in a hash map okay, once constructed, entries can be added or removed from a hash map using the functions assoc and dissoc. Retrieving or update values in a dictionary. Index into the dictionary using a key. So here's where we would show to use get. Let's see. Can be done using get. So here we would just have a simple example like over here. Actually, I want to keep the I'll keep the same example as we have here. So this would be a map called numbers. Okay. So we will def numbers. And so we'll have 1, and 2. All right, now setting the value. Yeah, so that's where we'll show how to use assoc. Yeah, so I'll have that after that. let's see, we wouldn't say it like that. Let's say new values are added to maps with the assoc function. Yeah, I like that wording. And so this would be assoc numbers do or do. Okay, and that would, yeah, let's see, can I actually evaluate this? No, this, let's put this over in the Clojure file. And then we need a key. So we would say 2, like that. All right, that's why I test everything. So yeah, I don't like that wording set, because we don't set anything in Clojure. We produce a new hash map. So I kind of want to say it like that. I don't know. Is that that might actually be overcomplicating it? Yeah, I think that's fine just like that. Let me print the return value. So that's over here. Because yeah, it is important, because we need to emphasize that the original map remains unchanged. And to get the new value, it needs to either be captured in another variable, or the return value needs to be passed along through a closure or something. I bet it says something like that here. I'm surprised. Lots of times when Clojure data structures are described, whenever they mention things like changing, they'll actually put it in scare quotes, because all of the collections are immutable. So nothing is ever really changed, but it doesn't seem to mention that on this page. Let's see if I said anything like that in the vectors exercise, because yeah, it was an interesting time porting the arrays exercise to Clojure because, well, here we also use assoc to update a value in a vector. Yeah, here's where I said it. Functions for operating on vectors will return a new vector while the original vector remains unchanged. Yeah, I kind of want to just copy that sentence. Okay, so functions for operating on, now they're really just called maps. I want to, hashmap is a hashmap, or simply map. That way I don't have to say hashmap all the time. Functions for operating on maps will return a new map while the original map remains unchanged. The values in a map. We love to conserve keystrokes. Rich Hickey chose nil over null for, well, a couple of reasons. One of which is that it's a little bit shorter. And okay. Retrieving values in a hash map can be done using get. All right, so now we want to get the element with key 2. Okay. You can test if a value exists in the map with and instead of contains key. So let's see, we're checking if some key that exists. This isn't like, does that even make sense? What I want to do is something like contains numbers 2. Yeah. So that's the contains predicate function. Okay. Now we don't need anything like this. Yeah, actually I should mention that maps can be sequenced. And then, because that's the beauty of the seq abstraction, is that they operate over any of the collections can be sequenced. So, let's see, does it say anything here? And of course, I will link this at the bottom of the page here for the student to be able to get more information. So this will, oh wait, let's see. This is for indexer properties. Where was that even? Huh. There's a link here that is not even in the document. And yeah, it's the point of the introduction is actually not to provide links. We just want to give the student just enough information to be able to solve the exercise without, so yeah, won't even bother with that here. So yeah, I think that's good for at least to start the introduction. And actually, I want to discard these changes because that was just scratch code. And I'll say create introduction. Okay, and yeah, I think I'm actually gonna wrap this up. Wait, no, I didn't want this here. But yeah, I think that'll be good for tonight's stream, and I'll continue this, and we'll do more C#. Yeah, I plan on probably doing this almost every day. I don't want to have a schedule, like formalize it, because I want to always make sure that I do it when I feel like it. But who knows? If we get into a rhythm, then I'll start scheduling it and announcing it. But thanks for watching.